Okay, so in this video we're gonna do the averaged version of version of let's say theorem 1.10, and what we're gonna do is so this is from IUT 4, so this is the version of Szpiro inequality, and so we're just gonna kind of collect all our formulas. So recall that that assuming from corollary 3.12, after averaging, we get we have the following. We have that minus the degree here of p q, okay, is less than or equal to, and then we had a bunch of expectations. So we had so we have the sum over p, and so we had the sum over p minus, so let's write this here. So we had let's say minus the two averages, so over the label, or over the valuations, then over the labels here, underline this, j squared. Okay, so there's this one, ln p. Then there is the different term here, p squared. So then we had the different. Oh, that messed up. All right, minus the other different. Okay, this has a log. All right, so then, so this is too many parentheses. 1, 2, 1, 2. So this is too many parentheses right here. Okay, and then there is so that, what other terms do we have? So we have the so we had this term that was, so this term can be improved a lot. 1 plus j plus 1 natural log of bp here, one ramification. There we go. Then we had the sum of I is equal to 0 up to j of natural log of e vi over p, like this. Okay, so we have all these terms here, and it turned out, so this is this version here. So this is kind of like post-average version, and it turns out that this. So what do we have? So this implies, after we collect everything, that that you know that this here well, let me just keep, I guess I'll just keep flipping back and forth. Right, so this implies minus the degree f naught pq. Okay, so this is less than or equal to. Now the first term became this LGP theta link, LGP, or is that not LGP theta link, the frickin' the theta pilot object. Okay, the next term became this different term, so this is plus L plus 1 over 4 ln, and I guess we could just call this the average different, plus so now we have some probabilistic terms. So this is a sum over p here of 1 minus here the probability that something's unramified, p L plus 1 over 2. 1 plus L plus 1 over 4 natural log of BP plus L plus 1 over 4 times the sum over P natural log of EP bar. Okay, so where here, this different here is this the natural log of the product, or sorry, is the, let me do this. It's the product of these local average difference. So it's like P product of over P of P to the diff P bar, where this diff P bar, this average different power or different valuation, is log P of this, the expectation of P to the diff, this different exponent. Okay, and then E P bar is just the average, the expected value of the ramification at P. Okay, so we have so that kind of, let me box this. This is kind of one of our formulas that we have. All right, and then in addition, what we could do is we could, so let me just we also use the information that we have about, so this is a nice formula on its own, okay, but we can also use the information that we have about these two quantities, okay. The first bit of information that we have is that this thing here, F naught here, let's just do the positive version, P theta. So this is this degree of PQ times L plus 1 times L over 12. Okay, so this term is now quadratic. Okay. All right. So that's going to be the first replacement, and then the next replacement that we have is that is the relation between this PQ so this thing is the log of the norm of the minimal discriminant of the conductor over F. So then there's a 2L here, and then there's the degree. Okay, so this is where the minimal discriminant comes in. All right, so this was the other piece of information that we have. So let's put this together. Okay, so let's start over here. So so this can go to the other side. So here we have L plus 1, so this is a minus, so now it becomes a plus. L plus 1, L over 12, right? Minus 1, now we have this RKL of degree here, PQ, right? And then we have a bunch of L plus 1 things. So then we have L plus 1 less than or equal to L plus 1 over 4. Okay. So then we have the log of this average different. And then we have the average ramification. All right. And then we have, at the end, we have what? We have our, at the end, what was our last term? And then we have this screwy term here. So that's the sum over P. Okay, so then 1 minus the expectation that a given prime will be unramified to the L plus 1 over 2, I think. And then we have 1 plus L plus 1 over 4. L plus 1 over 4. Then this natural logarithm term. Ln BP. Okay, so this is a very nice formula as well. Here, ln BP, so BP is P, so this is for P not equal to 2. Ln, so we're assuming that P not equal to 2 is not ramified in this expression. Okay, so we have this doodad here. Okay, so now I'm gonna bring all this stuff together and kind of write this in a let me adjust this one more time to make it look a little bit better. And so here I want to bring this term inside here. Okay, so we have L plus 1 over L plus 1 times L over 12 minus 1 times 4 over L plus, well, let's not do that quite yet. This thing minus 1, and then we'll do a 1 over 2L. And then we'll do natural log of the norm of the minimal discriminant. Then we'll have this degree. All right. And then this will be less than or equal to, okay, so then we have L plus 1 over 4. We're going to bring that over to the other side eventually. We have our different term, the average different. Then we have our averaged ramification indices, sum over P. And then let's bring this one in as well. So we have plus sum over P, 1 minus this probability that it's unramified, to the L plus 1 over 2. Then we have natural log of BP. And then finally we have this natural log of BP, and then we can do this plus 4 over L plus 1. Okay, so this is kind of, these are the main terms, and that thing's kind of vanishing. All right, and so this tells us, so when we bring this over to the other side, what we're going to have to examine is the following product. So it's L plus 1 times L over 12 minus 1. Then we do 1 over 2L. And then we're going to do 4 over L plus 1. All right. So let's bring this term in first. All right. And this one becomes, so the L plus 1's cancel. So it's L over 3 minus 4 over L plus 1. And then 1 over 2L. And then we have, so this is equal to the 1/6 minus 2 over L times L plus 1. All right. So this is this here is the 1/6. All right, so that's the magical 1/6 that we're looking for from Szpiro's inequality. And all right, so now what? So if we use this 1/6, we can actually okay. What I want to write this thing as so let's just kind of like clean this up. Okay, so 1/6 minus 2 over L times L plus 1 can be written as 1 over 6 plus epsilon L, where this epsilon L is, and I have a formula for it where I wrote it down. The computer wrote it out what it was. So epsilon L is equal to 72 over L plus 4 times L minus 3. Okay, and the way to do that, okay, so this is epsilon L. Okay, so so the way to do that is that you just kind of, so the idea is you use this equality here, you expand these fractions, and then you take the reciprocal and solve for epsilon L. And it turns out that the numerator cancels and everything. So this is like, O, whatever, L squared. Okay, so let's put this all together. And when we put this all together, we end up getting the following. So we get that we get the following inequality. So it's 1 over 6 plus epsilon L, natural log of the minimal discriminant of E over F divided by this degree, F over Q. Okay, this is equal to, or this is less than or equal to, natural log of the different term, the average different, plus the sum of the average ramification indices, right, plus some factors coming from some more ramification stuff. So all this stuff after this different term can really go away. You can fix it. And then this is natural log of BP plus 4 over L plus 1. Okay, so this is the inequality here. So this thing here is the averaged version of like Machizuki's theorem 1.10. Okay, and so what? So okay, so maybe we can say a little bit more about what these just, well, I guess we copied down what the epsilon is here. Okay. Yeah, and so that's I'm gonna play with this thing a little bit to see if what else we can get out of this. Okay, that's the end of this video.